Alright, time for the Prove Geometric Shapes assignment. So what you're doing on this is it'll ask you to prove that a shape is a certain type, and you just prove it algebraically. To do that, you need to get the slope and the length of each side, and then you'll write up, based on those, based on the slopes and the side lengths, how do you know it's a rhombus or a parallelogram or a rectangle or a square or whatever. Okay, so here's number one. When you see like PQ next to each other or SP, that means you need to get the distance from S to P. And so in order to do that, you need to get your coordinates for your shape. And so I highly recommend doing that. I'm going to do that real quick. So I got my coordinates really quick there. So if I'm trying to get SP, I'm going to just use my distance formula. P is x2, y2 because it's farther to the right in comparison to S. And so I need to get negative 2 minus negative 5, square that guy. And then I need to add 2 minus negative 2, and then square that guy. And we're looking at negative 2 minus negative 5 is 3. Square that, you'll get 9. And then 2 minus negative 2 is 4. Square that, you'll get 16. And 9 plus 16 is 25. Square root of 25 is 5. So I have my length there, it's 5. The slope from S to P is rise over run. So how far do you go up? Over how far do you go to the right? Well, you go up 1, 2, 3, 4, and you go right 1, 2, 3. So you're looking at 4 over 3 for your slope there. Here, I'll make it a little bit smaller. I'll make it a little bit sideways too. Okay, and so there we go. And if you look at all your slopes here, if you're trying to go from P to Q, you have to go down 4 and right 3. So your slope there is negative 4 over 3. Slope from Q to R, or rather R to Q, is up 4, right 3. And so that's going to be positive 4/3. And the slope of RS, or rather S to R, is down 4, right 3. And so that slope is going to be negative 4/3. And so that's a slope for all of them. And if you notice, since they all share very, very similar slopes, and that's directly from like P to Q or R to Q or S to R, when you're trying to get your distance for these guys, it's all going to be the same as well. Even like if you were to use this formula for all those points, you're going to get the same thing, because the x2 minus x1 stuff is just getting the run, and then y2 minus y1, that's getting the rise. And so distance formula is really just run squared plus rise squared, and then you square root it. And so all these lengths are all going to be 5. Okay. To prove that a shape is a rhombus, you need to have it be a quadrilateral, which this one is, and the lengths, the side lengths, have to be the same. And so, in your little explanation, you'd write something like since, and then you're going to write down that these 4 sides are all 5, you have a rhombus, because that's your definition for rhombus. Look on your notes for definition. So since SP is equal to PQ, which is equal to QR, which is equal to RS, quadrilateral, SPQR is a rhombus. And that's the explanation we're looking for. If you move on to 2, Again, I highly recommend getting your points there, and so I'm going to get those real quick. Okay, I got my points written down. On this one, we're supposed to prove that the shape is a parallelogram. In order for a quadrilateral to be a parallelogram, the opposite sides need to have the same slope. And it also has the feature that the opposite sides are congruent to each other, meaning they have the same length. And so on this one, really we just need to prove that the opposite sides are parallel to each other. And so on this one, if you just get the slopes, this one would be pretty much done, but it's also good to get the lengths because these sides are going to be congruent. Oops. And so we're going to do that. Let's start with AB. AB, the distance from A to B, is equal to, and we got this big old square root thing here. B is far to the right, so that's going to be x2, y2. 6 minus negative 4. Square that. And we have to get 6 minus 2. Square that guy. 6 minus negative 4 is 10. Squared is 100. Whoops. 100. 6 minus 2 is 4. Square that, you get 16. And you're looking at the square root of 116. And if you look at KE, if you get the change in the y, that's also 4, which is the same as the one we got on AB. And you look at the change in the x's, you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's actually the same change in the x as it was for AB. And so KE, also the distance is the square root of 116. I'm going to use M to represent slope, so the slope of AB. Well, to get that, you just need to get rise over run. The rise is 1, 2, 3, 4. And the run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're looking at a rise over run of 4 over 10, which reduces down to 2/5. The slope of KE is actually the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then rise 1, 2, 3, 4. So yeah, again, the slope is going to be 4 over 10, which, when you reduce it, you get 2/5. So we have same lengths, same slopes. We just need to now get KA and EB to be the same as well. So let's get KA, the distance from K to A. A is far to the right, so those coordinates there, negative 4, 2, are x2 and y2. So in our formula, you get negative 4 minus negative 8. Square that, add 2 minus negative 4, square that guy, and when you get that, you're looking at 4 minus negative 8, negative 4 minus negative 8 is equal to 4, square that, you'll get 16. 2 minus negative 4 is 6, square that, you get 36. 16 plus 36 is 52. So square root of 52, so that's our change there. And if you look at your that distance for both KA and EB, the change in the y for both is the same, which is a change of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so the change for both the y's is 6, which is where the 36 comes from. And the change in the x for both is 1, 2, 3, 4. 1, 2, 3, 4. And that's where the 16 comes from 4 squared. And so EB is actually the same as KA because the change in x and y is the same for both. And so those are both equal to square root of 52. We now need to look at the slopes of KA and EB. Well, the rise, which I already mentioned, is 1, 2, 3, 4, 5, 6. And then the run was 4. 1, 2, 3, 4. So you're looking at 6 over 4, which when you reduce it is going to be 3 over 2. And the slope for EB is equal to that same thing because it shares the same rise over run relationship. And so we have equal sides, we have equal slopes, and so in your explanation, here I'm going to put a little line here to split it off. In your explanation, write that out. So you'd say something since EB is congruent, distance from E to B is the same as the distance from K to A. The slope of KA is the same as the slope of EB. KE is the same distance as AB, and the slope of AB is the same as the slope from K to E. That should be an E. Quadrilateral KABE is a parallelogram, and that goes there on the end, and that's how you're gonna write it up there, okay?